Texture packing is one of the techniques used by game developers to boost performance of their games. It's relatively simple to implement and use. First, I will explain the basics of how loading resources to GPU works. Then you will see the custom packing algorithm in action. Also wait till the end of the video, as I have some exciting news to share. Now, let's establish basic definitions. First, a texture. We can think of it as simply an image. The game, during runtime, will load those textures into VRAM, your GPU's memory. If the given game has a lot of textures, then it might be necessary to swap them when there is no more available space. For smaller games, it's simple to load all textures at the start and keep them in memory during the whole game runtime. Note that the texture swapping is quite a performance-heavy operation. Another term we need to get familiar with is a draw call. I'm of course oversimplifying a lot, but we can think of it as a single command sent from CPU to GPU, which orders the rendering pipeline what should be drawn on screen. Again, as with texture swaps, it's best to minimize the number of draw calls in the single game frame, as there's some overhead associated with sending commands to GPU. And finally, sprite batching. This is a technique that minimizes draw calls to the GPU by, as the name suggests, batching sprites together and sending all the information needed to render them in a single draw call. The caveat here is that batching can only be used if all sprites in a given draw call use the same texture. This is at least how it works for those libraries and engines. The worst case scenario here is when we render sprites with different texture interchangeably. Then no sprite batching will occur at all. And that's where texture packing comes in. Texture packing simply means that a bunch of textures are packed into a single bigger texture. This final, packed texture is often referred to as texture atlas. Using it has several advantages. The most obvious is enabling better sprite batching, as fewer texture changes occur. Second, if textures used together, for example for one specific location in the game, are kept together, this could help guide texture swapping in VRAM. I don't bother with this case, as textures for my pixel art game don't take a lot of memory. Finally, an improvement that maybe isn't as significant in the age of SSDs, loading a single large file from a hard drive is much faster than loading plenty of smaller files. This results in faster loading times. Yet, during the game development process, it's easier to work on each texture separately. That's why often texture packing software is used. This software will create texture atlases automatically, together with metadata that describes where each texture was placed inside atlas. Now, I thought it would be easy to build in Texture Packer into my engine, so let's see that in action. Previously, I mentioned that when working on Pumpkinman, I was creating Texture Atlas manually. Caveman style, as Empanada called this technique in comments. This time I did extensive research on different texture packing algorithms, meaning I spent 10 minutes googling, and my overall conclusion is that it's possible to go fancy with the algorithm, but the simple solution is almost as good and faster to implement. The naive approach to texture packing would be to just go through all textures and place them one by one, yet this approach can result in a lot of unused space in Texture Atlas. Packing performance can be increased by simply sorting textures by height before packing them. This way, big and small textures are separated and the amount of space wasted is limited. Since the last update, I extended my game with this texture viewer. I can use it to preview every texture which is currently loaded into memory. For example, these are textures for sprite fonts used. I also added this current view indicator on the bottom. You can also see a texture atlas here. Right now it's created automatically at the game start, so I can test that the texture packing algorithm works correctly. But when the game will be shipped, the atlas will be just its own file. Now I can add a new file to the assets directory, hit repack, and the texture atlas will be generated again. All this optimization might be a bit of an overkill, but I think this is an easy win situation. Adding texture packing is, in the end, quite simple. Saved resources can be used for more interesting stuff than moving memory around. We should also keep in mind that a lot of gamers don't have access to high-end hardware, and for games like mine, it's expected that they work well, even on very old devices. Now the news I promised. The Pumpkinman Demo will be released on September 12th on Steam. Add Pumpkinman to your wishlist right now so you don't miss it. Remember that saves will transfer to the full game if you decide to try it out. Link in the description. And another update, I'm finally stepping up the Discord game. Join with a link in the description for weekly updates on development progress, new video notifications, more in-depth technical discussion, or if you just want to hang out. Everybody's welcome. And that's all for today's video. Subscribe for more and leave a comment if you have any questions. I will be back in 2 weeks with another video. Have a nice day.